Hi, Year 10s. This is a video on compound interest, 3L, second last that we're going to do for the year, and then we're done. I'm going to just go through the compound interest formula. We've already been through that, but just sort of more looking at that in terms of years and things. But what about if we were to have different amounts of time periods, such as months and daily and things like that? So that's what I'm going to be going through today. Just quickly, just to revisit now, first of all, the compound interest formula. This is what we've been looking at so far. We need three things. You need the rate, okay? You need the rate, the time, how long we're doing it for, and also the principal. Okay, so principal still is going to apply when we're looking at a more advanced version of this. And of course, our rate, well, let's say if it was growing, we'd sort of say something along the lines of this. So we're going to have we need the rate and we need the time. So when doing some of these, I just want to fill in these gaps for you. If I had a $700 invested, then the principal, the 700, would go out the front. 8%, how do I get that? Well, 1 plus the rate is 8%. 8 over 100 as a decimal is 1 plus, well, let's get the 8. 1, 2, let's move it 2 decimal points back. So 1.08. And 2 years, there we go, to the power of 2. Likewise, if I had 15%, that is going to be 1.15. Why? Because 15 over 100 as a decimal is 0.15. So that's 1.15. 6 years, to the power of 6. And of course, this time I want 6% per annum, so 6%. You need to be able to convert that decimal percentage into a decimal. So that's going to be 1.06. And if we're doing that over 4 years, compounded over 4 years, to the power of 4. All right, now, so this is, we're just revisiting this formula, but in particular, in a second, we're going to be looking at a different version of this, because we're not always looking at years. We can be looking at months and quarters and all those sorts of things. Okay, now look, the power of compound interest is, if I had just simple interest and I was just getting, let's say, 10% for 20 years, and I started off with $1,000. Well, after 20 years, you would earn $2,000 interest. That's simple interest, though. Okay, so there's no compounding. It's just at the end of the year, you just get 10% on what your principal was. That's not how things work in the real world, because we compound. You add money, you get interest each month, and you're building interest on the interest you've already earned. As you can see, more than if you were to compound interest, let's talk about sort of maybe monthly, then you'd have more than $7,000 if you invested $1,000 over 20 years at 10%. So this is due to this compounded. This is, I guess, the power of compound interest. It's really powerful. Okay, and that's why we do it. But banks, they compound daily, and then you might get paid interest monthly. The more compounds, the more money you're going to earn. Okay, so let's have a look, and let's start off with just the basic compound interest first, where we're compounding annually. We've got 8%, so with three things we need to know the rate, we need to know the principal, and the time. Okay, so we're doing it for 5 years. And of course, how often we're compounding is sort of another important thing. So let's do this together. First of all, let's write out what our formula is. It's growing, so we're going to need this, and to the power of n, which is how many years in this case. All right, so we know that the principal is equal to 4,000, and we know that the rate is 8%. So this is as a percentage, which will convert to a decimal in a second. And, n is 5 years. So if I want to work out how much my investment would be after 5 years, given this, the amount would be the principal, 4,000, always comes out the front. Now, 8%, that's going to be 1 plus 8 over 100. Well, that's the same as 1 plus. Let's do 8. Let's divide that by 100. Go 2 decimal points back. So that's 1.08. 1.08, and that's to the power of 5 due to 5 years. Now, if I go ahead and do that in my calculator, I won't share my calculator. We'll just, what will I get? $5,877.31. All right, now, as you can see, the 3 or 4 things you need to know is how often are we compounding. We're going to look at different compounds later, not just annually. We're looking at the rates, and we're looking at the principal, and how many years in this case. All right, now, I'm going to leave that up here, and I'd like you to try this example here. I'm going to pause it. I'd like you to try it, see if you can get the answer. All right, I'll be back in a sec. All right, so hopefully you've given us a go. So principal, we've got our principal here. We've got how many years. We've got our rate, which you convert to a decimal, and I got $4,512.19. All right, hopefully you got that. And now let's sort of break it down a bit more. So realistically, like we start off with looking at years and compounding annually, but this isn't really what goes on in real life. You earn interest on a monthly, you get sort of paid on a monthly basis from your bank. So let's have a look at this time. I guess this here can be, we could consider that what happens if we're looking at compounding per month. So if I had 5 years, then 5 years times 12 months is 60 months. Okay, 60 months. Now the thing is, though, wouldn't it be nice if you could get 5% per month from the bank? No, look, the rate can stay the same. If you're getting 5%, they're going to split that up into 12 months. So I guess what we're going to look at in a second is we're going to look at that this rate also has to, if we have, for example, if we have compounded monthly, then what that means is that we're going to have to split that rate up. Okay, so let's go ahead and just start. Before we do that, let's start thinking about some new time periods. So in this case, we're looking at monthly, and we're looking at quarterly. Okay, so first of all, if I was to go ahead and my compound interest formula is this guy here, 1 plus R over 100, and that would be to the power of sort of some time. Now, if we're paid monthly, then what we're going to do is we're going to have to bust this rate up. Okay, so let's divide that by, let's get that, so at the moment, we're getting 6% per annum, per year. Well, what is the monthly rate? We're going to work out what the monthly rate is. Okay, so the monthly rate. Well, it's not 6%, it's 6 divided by 12%, okay, which is 0.5%. Okay, now I've got that as a percentage, so we can go ahead and work that out and use as a decimal in a second when we practice that. And likewise, if I've got the monthly rate, well, let's have a look at our time period. Our rate is per month, so we've got to work out how many months there are. So 4 years times 12 months is 48 months. Notice that our rate is per month and our time period is also months. So 48%, this is 0.5% per month. Yes, it'd be nice if they gave 6% per month, but they're not. They're going to give you, they're going to divide that per annum rate into 12 even lots, and you're going to get 0.5% per month. And as it turns out, as I sort of talked about before, that compounding on more regularly is going to get you more money. Okay, now won't be a great deal, but it'll still be something. All right, now let's have a look at this other one. This time we've got 18% per annum over 3 years, but paid quarterly. Well, quarterly is a quarter of a year. There's 4 quarters in a year. So let's have a look. Let's work out the time period. Well, how many quarters are there in 3 years? Well, 3 years, there's 4 quarters. Okay, so there you go. That's going to be 12 quarters. So what are we going to do now? We have to find our rate. So it's not our rate per month, it's our rate per quarter. How many? Now, we've got 18%. Instead of dividing it by 12, we're going to divide it by 4. Okay, which is about what's that? 4.5% per quarter. All right, so once again, rate per quarter, 4.5%. We've got 12 quarters. Now we can go ahead and start using the formula. So really, this is what goes in the background when you're doing these questions. Now we're introducing, quarters and months and even daily. Okay, I'm going to leave that up there. I'd like you to try the similar one for this. I'm going to pause this now, have a go, and I will reveal what the answers are. Okay, so now I've got my solution up there. This is what's going on in the background when we're sort of looking at months and quarters. So first of all, you can see here that we're paid 5% per annum. That's per annum per year. Well, we want to compound it a bit more regularly. So we're going to look at the rate per month in this case. So we're going to have to bust that up. Now, 5 divided by 12 is sort of this ugly-looking decimal, 0.4166. Well, later on, I guess what I'm saying is if you just do it in your calculator as 5 over 12, and then you can put it in the formula, you can actually, so I'll go through an example in a second where I'm going to just do this in the calculator, okay? And you shouldn't have to do any sort of rounding. This example here is not ideal because that's the percentage you'd have to put in. And if you round it to 2 or 3 decimal places, you're going to miss out on the exact sort of figure. And it could be working out a fair bit if you had a fair bit of money invested. All right, and finally, if we're looking at the rate per month, we want to find the time period in months, which is 60 months. Okay, 5 years times 12 months is 60 months. Rate per quarter, well, there's 4 quarters in a year, so we're going to bust that rate up to 3.5% per quarter. And the time period, well, we've got 3 years times 4 quarters is 12 quarters. So we have to get that rate and that time period to match up. That's, I guess, probably the part that you need to sort of really consider. All right, now let's do this example. Anthony's investment is $4,000. Now let's get a highlighter out, and this is what you should be doing, taking note of this. These are the things we need. We need the principal, which is $4,000. It's compounded at 8.4%, so that's our rate. It's over 5 years, but it also says determine the amount if the interest is paid monthly. So, of course, it's compounded monthly, so we're going to have to find that time period and the rate per month, not the rate per annum, like we have here. Okay, so that's the first thing you do. Now, what do we do second? Well, I guess let's write out what we know. The principal is $4,000. The rate, let's do the rate per month. Okay, so the rate per month would be nice if we can get 8.4% per month, but we're not going to get that. The rate per month is 8.4. And what we're doing is we're dividing that by 12. Okay, now if I go ahead and do that, that's going to give us 0.7% per month. Okay, so that's going to give us 0.7%, which is 8.4% divided by 12. And of course, we've got 5 years, but what is the time period? Well, if we're looking at per month, how many months do we have? So we've got 5 years times 12 months, which of course is 60 months. Okay, now I've got all of that. And now, I guess in the formula, so my amount at any time is my principal, 4,000, that goes out the front. The thing is that this 0.7% really can go up here as a percentage. It could be 0.7 divided by 100. And that's then going to give me my rate as a decimal. This growth rate, if you like, we'll call that A, which we have in the past. And now we've got, this is our rate per month. This is our rate per month as a decimal. So we need the amount of months. Okay, so the amount of months or our time period. So what we're looking for is 60 months. So that's to the power of 60. If I go ahead and put that in my calculator, now look, let me show you how to, if we wanted to do this all in one hit, we could do that. So let me go to the calculator and let me show you this in the calculator. All right, now, first of all, the amount is 4,000. That's how much is invested. If I want to use this calculator, I don't have to do that. I can actually use this 1 plus, and what we want is we want to bust up that 8.4%. We want to bust that up. So as you can see, I've done control divide for a fraction. If I do control divide again, it's going to be a fraction on the fraction. We can do all of that in one step. All right, so 8.4, I want to divide that by 12, and then of course divide by 100, which will give me, because that's to give my decimal. Now, of course, I now want to do that to the power of, well, we're looking at 5 years, and 5 years with 12 months, so that's 60 months. If I go ahead and do that, I press enter, away you go, $6,078.95, rounding up. Now, if I want to go and from there, what about this? I just want to show you what a lot of students will do with this. What they'll do is, I guess this one's sort of not so bad because it's exact. If I do 8.4 divided by 12, that's 0.7. That 0.7 goes here. So look, that's fine if you want to do it, bust it up that way. You're still going to get the same result. Okay, you're still going to get, if I was to do that in 2 lots, I work out my percentage, still over 100, then that's to the power of 60. I'm going to get exactly the same result. But the example before, where I looked at something along the lines of 5% divided by 12 months, well, 5 divided by 12 is this. Okay, so if we start doing rounding, we're actually going to be costing ourselves some money. So what I'm going to suggest is if this rate was, if I wanted to get that, and I wanted to do that, I could go ahead and I could go control divide, and I could do 5 divided by 12 and just put it up there in the calculator. It's only going to do we can only do rounding at the end then. Okay, so that's going to give me sort of some value. Whereas if I did the decimal point value, let's have a look at the difference between if I did that compared to our decimal point, which was, let's just delete that. And it was, if I did some rounding, 0.4167, for example, then there's going to be some difference, not much. You know, we're looking at sort of 10 cents or something like that. But yeah, try to, if you can, use this in the calculator. This is the exact value. This is one that you've rounded off. All right, now that I've been through that, I'm going to get you to pause this and let's see if you can do this one by yourself. If you can do it in your calculator like I've shown, fantastic. You can do it one less step, fantastic. All right, I'm going to get you to try this. Pause it now, give it a go, and I'll review my solutions. All right, so I've got my answer there. So when you tackle these questions, first of all, get your highlighter out or make note that we've got so we want 3 things. We want our principal, we want our rate, and of course how many years. Now from there we've got to work out our monthly rate. So as you can see, if I divide that by 12, that's going to give me a decimal, and which we can put it straight in the CAS. If I put that straight in the CAS like this, then I'm not going to be getting any rounding errors. And time period is, 4 years times 12 months is 48 months. So that's going to be up here. So remember, I've got a rate per month. This needs to be months. All right. Now I got $8,964.49. Now, of course, let's just practice once doing it in the CAS. I want to get, so that's going to be 7,000 times, well, we've got 6.2%. So we're going to have to do control divide. And here's a fraction. If I want another fraction, let's do control divide again. So if I do that straight in the calculator, 6.2 divided by 12 and divided by 100, that's going to give me my decimal value there. All right, if this was quarterly, then I'd have to divide that by, I'd have to divide that by 4. Okay, and then we're looking at, what was that, over 48 months. So we want to then do to the power of 48. And there you go. As you can see, if I was to do this 6.2 divided by 12, and I was to then sort of, let's just say that this thing over here, instead of that, well, we're using a rate of, let's say if I had 1.0516, and if I just use that for example, let's see the difference. Well, we don't want that. Let's try this. I didn't add another 0. Okay, so there was a difference of around about almost $3 there. So just note that if you can try to do it in your calculator like this, it's gonna make life a lot easier for you, and you're gonna have less rounding errors. All right, so that's about it for me. Try the coursework from 3L. There's not a great deal there, so you should be able to get this done in your working lesson. All right, I'll leave you to it, and take care.